And now in this video I'll be doing one more discrete probability distribution, that's a Poisson distribution function. This owes it to the French mathematician, that is the Poisson. He gave this in 1781, and now this distribution is used to in many processes, like the, say for example, the distribution of telephone calls. Say for example, the distribution of telephone calls. It may be used for the hospital services for patients, and so on. Now, the one of the most important things is that the one of the most important common element over here is that the variables that we are taking, or the discrete random variable that follows a Poisson distribution, is it takes an integer, whole values or whole number. Say for example 0, 1, 2, 3. Now let us take an example. Say for example, the number of patients that arrive to a physician in a hospital, they are 1, 2, 3, 4 and 5. So in this case they take a whole value, or the whole number, and in this case the number of phone calls can be 0, 1, 2, 3, 4. So these random variables take the integer or the whole values that follow the Poisson distribution. Now let me take the example of the number of cars coming in the service station, and then explain the various characteristics of this Poisson distribution. The first one is that the average number of vehicles that arrive can be estimated from past data. So this is one of the characteristics of the Poisson distribution. In this, the past data helps us to find out the average of the current one. The second one is that the probability that exactly one vehicle will arrive at single booth for service will be very small. And then this third one is that the probability that two or more vehicles will arrive at a particular time is also small, that we can assign the value of 0. We can assign a value of 0 to it. So another important thing is that the fourth one is that the number of vehicles that arrive at one point of time are independent of the vehicles arriving at other point of time. Therefore, the number of arrivals are independent of each other. So in this case, if we look into this over all the characteristics of this Poisson distribution, we will see one of the most important condition that we are looking at. In this case, we are just looking at one possible outcome, that is the possibility of happening. We are not looking at the possibilities of non-happening in all these cases. So all these cases are just look at the possibilities of the happening, and however, we don't look at the possibility of non-happening in this case. As in the binomial distribution, we looked at both the cases, the possibility of happening as well as the possibility of non-happening. But in this case, we just look at the possibility of the happening. Say now average number of vehicles that will arrive, so possibility of happening. The probability that exactly one vehicle will arrive, again possibility of happening. Two or more vehicles will arrive, again the possibility of happening. So in this scenario, the Poisson distribution just looks at the possibilities of the happening. Now let me calculate how. Let me show you how to calculate the probability of the random variable x with the help of the Poisson distribution. So this is equal to lambda x multiplied by e raised to power minus lambda divided by x factorial. So in this case, this is simply the x factorial. Now this is the probability of x occurrences, and now this e raised to power lambda, so e takes the value of 2.71828. This is raised to the negative lambda power, and the over here this part is the it means the mean number of lambda over here. This lambda means the mean number of occurrences raised to x power. So over here the e exponent is raised to a negative power of the lambda. Now we will be doing some questions. We will be doing an example that will help us to solve the Poisson distribution. So the basic Poisson distribution is that when the possibility of occurrence is very small, in that case we use the Poisson distribution. And another important case is that it is a discrete probability function where we only look for the happening, we don't look for the non-happenings, and the probability of occurrence is very small. In such a case, the Poisson distribution is normally used. Now let me take an example to understand the Poisson distribution.